One reason to write tests for your code is to be able to change your code and still have high confidence that it works after the change. However, my experience is that sometimes the code is harder to change if it has tests. In this episode, we will have a look at one such test and also have a look at how we can improve it so that changing the code is actually easier. The example I'll show you is from my project RLCI. RLCI is an experimental CI/CD system that I'm developing using an agile approach. If you want to know more about it, check out the link in the description. Let's have a look at the problematic test. So here we have the RLCI app, which is a command line application. And it has two tests at the moment, so if you run it without arguments, it will print the usage, and the other branch is the trigger. So this triggers a pipeline. And this is actually the problematic test. So let's have a look at how this works. So when we run the RLCI app in test mode, giving it the trigger argument, we assert that something was triggered. Let's have a look at how this is done. So in the implementation of the trigger, we call the pipeline engine.trigger. And pipeline engine is a dependency to this RLCI app, and which is passed to the constructor here. If we have a look at engine, it in turn has a runtime as a dependency, and when the trigger function is called, it sends this trigger event and instantiates a pipeline and gives it a runtime and calls the run method. So what we have is a dependency tree like this. The RLCI app depends on engine. The engine in turn depends on the runtime, and the engine also depends on RLCI pipeline, and that in turn uses the runtime. What we're doing in this test is asserting that this trigger function of the engine was called. This test didn't sit right with me when I first wrote it, but I didn't see the problem clearly until I read the article "Favor Real Dependencies for Unit Testing." Then I realized that this test asserts that an internal dependency is called. If I want to implement triggering in another way, not using engine, I have to also rewrite the test. This makes the code harder to change. What to do instead? Let's have a look at my solution. Instead of asserting that an internal dependency was called, in this case, I asserted what would actually happen when a pipeline was triggered. And in this case, I chose to assert that something was printed to stand it out that a pipeline was actually run. And I also added a comment here saying that we just want to assert that the pipeline was triggered. We don't care about the details of how it was run. For the details, see the tests for the engine class. So we want to observe like externally what's happening when a pipeline was run. And for the moment, we can have a look at std out. But in the future, we might read from a database saying that an entry was created or something like that. So what happened down in the constructor here is that there's no longer the pipeline engine passed to the constructor. It is actually instantiated here. It's an implementation detail. The test up here doesn't care that the engine is used. We could inline this engine and this test would still pass. Here is the current state of the code, which is a little bit different but similar. So we still have looking in stdout for this message, but the implementation here is still similar. So we instantiate an engine and trigger something. The engine tests also assert that this thing is printed to standard out. So this is like a duplication of tests, which I'm fine with, creating overlapping sociable tests. But I'll just show you one consequence of this. So if we change the implementation here and print something else, test it out, let's see what happens. Now we get two test failures. The first failure is the RLCI app. So we're not seeing this, we're seeing this instead. And similarly, the test for the pipeline engine has the same kind of error. So we're seeing the error multiple times. So when we're using this approach of only asserting on like external dependencies, we get these duplicated overlapping tests. One way to minimize the negative effects of this approach is to try to assert less in this particular case. Here we're not interested in details of how the pipeline was run, so that's why we filter on the events and try to extract only some part that is relevant for this test. Whereas in the engine we assert, we don't filter the events, and we assert that a lot of more things happen. But I guess that's a trade-off you'll have to make. I hope you found this example useful. If you did, please give this video a thumbs up, and I'll see you in 1 week.